Starbase's second launch tower has surpassed its halfway point. Paperwork is already well underway to fly Starship 25 times a year from South Texas. A new booster is close to completion. We get an amazing look at the first fully completed Raptor 3 engine, and I can't believe it, but somehow there's even more to come in this Starbase update. Let's start off with Ship 30, the next Starship vehicle slated to fly into space. In case you don't remember, after its static fire test at Massey's last week, this ship rolled back to the production site and then was moved to the Sanchez lot. While it's been there, it appears as if teams have been working on its thermal protection system for the better part of a week. We could see how, as days went by, workers had added extra tiles on the forward flaps near the bottom hinge. This is very likely in order to avoid having the same issues we saw on Ship 29's re-entry, where a bunch of tiles came off from this specific point, and that led to the melting and disintegration of that part of the flap. Other work on Ship 30 that we saw seemed to have been on the payload bay section. Since then though, Ship 30 has been moved from the Sanchez site and placed in one of the work stands inside Mega Bay 2. It is supposed to be prepared for flight, but it seems like that may take a little while longer. Just the day after it arrived at Mega Bay 2, we saw an engine being taken out of Ship 30 and then being replaced by another one. In this case, they removed an RVAC serial number 398 with another one, serial number 384. It's not known why they had to do this, but this now has all of us wondering whether they'll have to perform more engine testing or not. We wouldn't complain if that were the case, because engine testing is always cool, but it also would mean Starship's fifth flight might be a little bit further away than we probably expected. In the meantime, Ship 31 continues to be worked on inside of the high bay, in the same corner where Ship 30 got its heat shield completely replaced. We're yet to see any substantial work towards this on Ship 31, but perhaps that may begin in the next few days. Or maybe SpaceX will wait until Ship 30 flies in order to do this overhaul on 31. We really don't know right now, but one thing's for sure, we'll be keeping a close eye on it. Remember, this ship should be the one to fly after Ship 30 and will also be the last of the current version of ships to fly.
Wait, never mind. SpaceX has just started the work on Ship 31's heat shield, so 1, ignore everything I just said, and 2, tune in next week to see how much work they've done.
But SpaceX is not just working on the vehicles for the next 2 Starship flights. Inside Mega Bay 1, SpaceX is building the booster that should be flying on the 8th flight of Starship, Booster 15. We already had seen its aft section rolling into the bay last week, which meant its LOX tank was complete and only the methane tank remained to be built. Earlier this week, we were able to spot the forward dome section of this booster being staged next to Mega Bay 1, which meant the stacking of the methane tank was about to start. Fast forward a few days and we spotted another methane tank section staged outside Mega Bay 1. Just to refresh our memory, a super heavy booster consists of 33 regular rings spread over 9 barrels and 4 short rings making up the barrel for the engine section. These are split into the aft stack and the forward stack, that are then joined together to form the entirety of the vehicle. The aft stack starts with the common dome section and then is followed by the aft 2, 3, 4 and 5 sections, all with 4 rings. This is then added to the aft engine section, and this gives you the bottom half of a super heavy booster. This is what I mentioned is already completed for Booster 15. As for the forward stack, it starts at the top with the forward dome section and then is followed below by the forward 2, 3 and 4 sections. The forward dome section and forward sections 2 and 3 all have 3 rings, and the forward 4 section has 4 rings. Well, the methane tank section spotted outside of Mega Bay 2 is the forward 3 section, as that one has the little booster stabilizer that you can see here in this clip. This essentially means that, once stacked to the other forward sections, Booster 15 is just 2 stacks away from being fully completed. The first stacking would be with the forward 4 section, so that the forward stack is complete, and then that would be followed with stacking of the forward stack on the aft stack to complete the vehicle. Given the rate at which they're putting this booster together, we could see a new booster being born in just a matter of days from now, which is a bit hard to fathom. At Starbase, not everything is all about production though. If you remember, SpaceX is building a fancy new office building just down the road from the bays and the Star Factory building. This week, teams have already started outfitting the exterior of this building, placing shiny new glass panels on its facade. In pure SpaceX fashion, the company is already applying white paint to this building so that it is up to the aesthetic aesthetic standard of black and white colours pretty much on every building. I mean, just look at the Star Factory or any other building they own for that matter. I mean, even the website. Moving back to the Sanchez lot, this week teams were also working on the tower modules that are being parked there until it's their time to go up to Pad B. In this clip, we can see workers already installing the scaffolding on module number 7 that will be used for tower stacking. Once this section is installed on the tower, module 8 will have to go on top, and that scaffolding will allow workers to access that connection between them and firmly secure the two modules. The fact that this scaffolding is being installed now also means that we're close to this section moving to the launch site and being installed on module 6. But for that to happen, there's still some work to be done, so let's go to the launch site and take a look at what's been happening this week and what else they need to do to get to that point. Last week's episode pretty much left off with the 4th tower module being installed on the 2nd launch tower at Starbase. Since then, it has been firmly secured to module 3, the section right down below, and another 2 sections have been added on top. Yep, in the span of a week, Tower 2 has grown quite a bit. In fact, it is now well beyond its halfway point. Both modules 5 and 6 were also installed pretty much back to back, one after the other, with not a lot of time in between. By the way, modules 4 and 5 are the ones that will eventually have the ship quick disconnect arm, but module 6 is already well above that. So if you take a look at it, you can see that it lacks any of the big propellant lines, although it does have a few hydraulic and power lines that run up the tower. Also, if you look closely, you can see it also holds one of the pulleys that is a part of the chopstick carriage system, pretty much like the Starship Tower at Launch Complex 39A in Florida. So now with all of the first 6 modules connected, what's next? Well, there are another 3 modules remaining, which are modules 7, 8 and 9. These, however, will not be able to be installed straight away. As stated in some documentation from the FAA a few weeks ago, the Terex Daymag CC8800-1 crane will need to be reconfigured with a longer boom in order to be able to lift these 3 sections to the heights they need to be lifted. So don't be too surprised if you come to next week's Starbase update and there hasn't been another tower lift. That only means they're still preparing the crane for the last sections to be stacked. However, if they go at a similar rate as with the previous 6 sections, they could really have the tower finished very quickly once this reconfiguration is done. It's quite impressive seeing that they're able to put this tower together rather quickly, given that every time they stack a new section, they have to join everything together. This is done by first bolting each section together and then welding them to each other to firmly secure them. This always needs a rather large team of people working around the clock to prepare each tower section, both the installed section and the soon-to-be stacked section. In order to get to those heights, SpaceX also installs a new section of the tower's elevator shaft so that it can go up to the top and let them access the connection point. So every time each new module is stacked and secured, teams have to remove the lifting load spreader from the crane. That way it can be used to lift a new piece of the elevator shaft onto the already stacked module and aid in stacking the following section. As you can see, this is quite a huge operation. And in fact, while all of that is going on, don't forget that there's still work ongoing at the base of the tower. After all, this section is the one that supports a lot of the tower systems and will be face to face with the fury of Starship's engines once they ignite. This is, for example, where the drawwork system will be located that helps to move the carriage system for the chopsticks up and down. And if you think that's all the work going on at the launch site, then you'd be very wrong. If you've been paying attention to the last few Starbase Update episodes, you may have heard that SpaceX is currently creating a new launch site entrance right next to Starhopper. As you will see later in the episode, this entrance is set to replace the current main one near the orbital tank farm. More work has been ongoing here for the last week or so in order to properly prepare this location for vehicles and other Starship hardware to go through. Here's hoping that at least what doesn't go through it are the dozens, if not hundreds of crabs that popped up around Starbase this week. Seriously, what's going on with all of the Starbase crabs? In any case, going back to launch site work, we also had a bunch of work at Pad A, the only currently active Starship launch pad. Although, given they have been removing pumps on the methane side of the tank farm for the past couple of weeks, it is temporarily disabled. It's nothing to panic about though, as they can bring new ones in rather quickly, but it's quite interesting that they're once again doing this type of work. This week we also saw teams relocating one of the thin vertical tanks at the tank farm. This was one of the tanks near the recondenser, which was also relocated last week as well. So both that recondenser pipe and this tank have now been relocated near the end of the tank farm extension. We don't really know why they've done this, but I guess now we'll just have to look this way to observe any recondenser activity. And to add to this, Mary also spotted this week teams extending the protection wall around the tank farm, which now reaches the end of the current tank farm extension. But soon, both this tank farm and the wall will get an even larger extension as part of the preparations for the second launch pad. This week, the FAA released the draft-tiered environmental assessment for SpaceX Starship/Super Heavy vehicle increased cadence at the SpaceX Boca Chica launch site in Cameron County, Texas. They really tried to give this document the longest name possible. This 143-page long document is essentially part of the paperwork needed for SpaceX to be approved for a series of changes that are either already in the works or about to take place. We have a half-hour-long video coming up where we go into the interesting details of this document, but for you all on a Starbase Update, very quickly, here's a short summary. While SpaceX already had an environmental assessment in place from the year 2022, SpaceX is requesting the FAA for an increased launch cadence of Starship from Starbase. On top of this, the launch pad outline has changed and Starship is about to grow by a lot and get just a tad more powerful than what was studied in the 2022 assessment. Part of the launch pad changes includes a change of location of the second launch pad, officially known as Pad B, from being south of Pad A to being west of it. SpaceX has also moved the majority of its testing operations to Massey's, which meant it didn't need any more suborbital pads or test stands at the launch site. This translates into freed up space to the west of the complex for Pad B and plenty of room to extend the existing tank farm and be able to share that across the two pads. Apart from an even larger tank farm expansion, SpaceX will include a new water deluge tank farm with greater launch capacity and an air separation unit all the way to the west end of the launch site. All of this will allow SpaceX to support an increased cadence. The company is requesting approval for up to 25 launches per year from the current 5 per year that are approved. Of these 25 launches, one of them may happen at nighttime or, as defined in the document, between 7 o'clock in the evening and 7 o'clock in the morning local time. 25 launches per year also means 25 landings per year of both of Starship stages. In this new environmental assessment, SpaceX added 2 new landing locations for Starship to land on. One in the northeast Pacific off the west coast of the US and Mexico, and another in the southeast of the Pacific, just west of Peru and Chile. As for super heavy landings, these would still happen either at sea or back at the launch site. However, SpaceX now says they expect to expend the hot staging ring approximately 20 times before moving to an integrated hot staging system on Super Heavy. Even if 20 is an approximation, a big exaggeration, and they do it only maybe 10 times or so, that's still quite a lot of expended hot staging rings, more than we assumed would be expended. This would also not bode well for the upcoming version of the Super Heavy booster, because it would probably mean we're stuck with Block 1 or version 1 for quite a lot longer than we expected. But in order to prepare for that, this assessment already takes into account the effects of the future, larger and more powerful versions of Starship. SpaceX once again listed that Super Heavy will have 35 engines, while Starship will have 9. Not only will there be more of these engines, but also each of these engines will be a lot more powerful, so eventually Starship's booster will have a liftoff thrust of over 10,000 tons. That's unprecedented. But to get to that impressive liftoff thrust, SpaceX will need a new engine, much more powerful and efficient than the current Raptor 2. This week we finally were able to see the first engine of this upgraded version of Raptor, the Raptor 3. It first started with Elon sharing this picture of Raptor 3 serial number 1, which means that this is the first Raptor 3 to come off the production line. The day after, we got another post, but this time from SpaceX, sharing more pictures of this first Raptor 3 engine along with specs for the engine. But before we get into all the specs and all, let's just talk about how it looks. I mean, it's just a lot more simplified. Even if you know nothing about rocket engines, you can tell it looks much more simplified. Not only that, but even the colour is different. Both Raptor 1 and 2 have that sort of weird greenish tint to them, while Raptor 3 is greyish, kind of looking more like a Merlin engine in some sense. We don't know why it is a different colour, but it could be some sort of protective coating. Remember, Raptor 3 has a lot more integrated cooling loops now compared to its predecessors, so perhaps some special coatings are needed in order to protect the engine and make it more reusable in the longer term. In some of the close-up shots, we can also see that this engine appears to be made of two halves, and the upper half is in fact the one that does not look to have that grey colour on it. Also, if you notice, SpaceX has gotten rid of a ton of flanges on Raptor 3, but they haven't gone away completely. The bottom grey section is all completely welded, whereas the top section still has flanges present. The upper section contains both the liquid oxygen pump and the pre-burner and the liquid methane pump. The bottom section includes the methane cooling manifold for the nozzle and the combustion chamber, and the combustion chamber and nozzle themselves, the methane pre-burner and the hot gas manifold. This massive simplification allows SpaceX to run this engine at very crazy pressures and temperatures, much more crazy than before, which is why this engine now runs at a higher thrust. So let's now go to the specs that SpaceX shared, because there's some interesting numbers here. As we already knew from Elon's presentation in April, Raptor 3 is capable of producing 280 tons of thrust, which is 50 tons more than Raptor 2 and almost 100 tons more than Raptor 1. That's some impressive iterative design process. Thanks to this post, we also know the specific impulse of all three iterations of Raptor so far. These numbers, however, correspond to the specific impulse of the sea level variant of Raptor in vacuum conditions. So for example, when Super Heavy is undergoing its boost pack burn, or when Starship is performing its orbital insertion burn and firing all of its sea level and vacuum engines in space. Raptor 1 had a specific impulse in a vacuum of 350 seconds, which decreased slightly to 347 seconds on Raptor 2. If you remember, this was because part of the thrust increase on Raptor 2 involved opening the engine throat a bit and also using a lot more film cooling. These two modifications decreased the efficiency of the engine and therefore its specific impulse. But with Raptor 3's design and manufacturing upgrades, SpaceX was able to return to the original specific impulse of 350 seconds while also upgrading the engine's thrust. These specs are really good, but perhaps what impressed everyone the most was the data of the engine mass and the engine mass while accounting for all of the extra bits that get added on the booster and ship. For Raptor 1, for example, the mass of the engine alone was 2,080 kilograms, but when you add on to that all of the engine shields, plumbing and whatnot, this mass increased to 3,630 kilos, nearly double the mass. Raptor 2, whilst being lighter than Raptor 1 by 450 kilograms, still had quite a lot of hardware added to it. The total mass of the engine, with all the vehicle side commodities and other hardware, amounts to 2,875 kilos. That's nearly 3 tons of mass per engine, and equivalent to almost 95 tons of mass just for the engine section of Super Heavy. One has to wonder what kind of vehicle side commodities and hardware mass SpaceX is including in these numbers though. There are a lot of things that can easily fall in this category, like the thrust vector control system, the engine shields, the false ceiling around the aft dome with both ship and booster, or even the mass of the entirety of the fire suppression system. This system has 2 big tanks of carbon dioxide and dozens of pipes that distribute this fluid into the engine section to purge it and avoid fires during flight. But almost all of that hardware that we just listed will be going away completely for Raptor 3. For that version, the engine alone will go a bit down in mass to 1,525 kilograms, only a 105 kilogram reduction in mass. However, the mass of the engine, while accounting for the vehicle side additions, only goes up to 1,720 kilos, a reduction of over 1 metric ton in mass relative to the same metric for Raptor 2. Of course, Raptor 3 will still have a thrust vector control system for the inner engines on Super Heavy and the ship, and it's very likely SpaceX will still keep the false ceiling on the aft domes to protect the wiring and plumbing of the dome. With this new version, the engine shields and the fire suppression system will go away completely, which translates into a substantial reduction of vehicle side hardware. Doing a bit of maths, it would translate roughly into about 34 tons of mass on the booster and about 3 tons of mass from the ship. This removal of unneeded mass means SpaceX can now use that mass margin instead to put more engines at the base of the rocket, stretch the stages and add more reinforcements everywhere. So when are we going to see this engine being tested? Surely if they're showing pictures of this engine, it must be because it's already been fired, right? Well, look again, and you may see otherwise. The first picture Elon shared shows the engine outside of the Raptor hangar at McGregor. We know this because our friend Blair regularly flies over the test site and captures photos of this location every now and then. and the trees and the building are pretty much the same as in the picture. From the other pictures SpaceX shared, we can also see the entrance to the hangar and the engine in storage inside of the building, and a lot of Raptor 2 engines. Just look at how many there are in this picture. When you think there's no more engines, you just keep looking and you'll find more in the back or some engine part sticking out. While Raptor 3 is definitely the star of this update, it's quite remarkable to see Raptor 2 engines up to serial number 569. Definitely not a small number. So Raptor 3 is not only at McGregor in those pictures, it is also installed on a test stand in one of them as well. You can see in there it is already fitted with the thrust vector control system and what appears to be a protection jacket around the liquid oxygen inlet. Because of the presence of a flame trench, we can immediately identify this as the Raptor vertical stand at McGregor. This stand has two bays, west and east, and this one, we can see,
is the East Bay.
Now take a look in the distance. You can see a Falcon booster vertical at the large site, which is where Falcon boosters are tested and also where the tripod stand is located, although it is just out of view in that photo. It just so happens that a new Falcon 9 booster went vertical at McGregor on Friday, just the day before SpaceX posted this picture. Furthermore, this stand, the vertical stand, has been inactive since July 25th, which was when the last test from here took place. From the comparison pictures with Raptor 2, we can see that the inlets for the methane and oxygen side of the new Raptor 3 engine are different, which means everything this engine connects to needs a new type of connector and plumbing. For Starship, this means a new version of course, but it also means the test stands at McGregor need to be reconfigured, and it's quite suspicious that this test stand in particular has been inactive for over a week. In conclusion, it's very likely that these images are very recent and that the vertical test stand has been reconfigured now to be able to test Raptor 3 engines, which likely means this stand will most likely not support Raptor 2 anymore, so stay tuned to McGregor Live because there's a potential for this or future Raptor 3 engines to be firing up from this stand in the next few days or weeks. Now, if you're worried there aren't enough test stands now to test Raptor 2, don't worry, SpaceX still has two horizontal stands and the tripod stand where they can test this engine, at least until they're also reconfigured for Raptor 3, if they are reconfigured. Our friend Gary Blair has also spotted in recent weeks work for not just one but two extra vertical stands at McGregor of the same size as the current vertical stand. We can already see SpaceX has begun digging a flame trench for these stands, and if they're designed like the vertical stand, this would mean each one could support two test bays. In total, SpaceX could soon have 4 extra test bays where they can fire up Raptor 3 engines left, right and centre. These vertical test stands not only have a flame trench, but also a proper deluge system, which would mean no one in any of the nearby towns would complain as much about the engine noise. Perhaps in the future, SpaceX may phase out the horizontal and tripod stands and just use all the vertical stands at McGregor. One thing is for sure, we'll probably need more cameras for that. It's been a long one, so thanks for sticking with me. I've been Caton for NSF. Thanks for watching, and goodbye.